How many of you were here in the reports presentation just a little bit ago? Most of you. That's good. I really appreciate you guys staying here out of pity for the person who has to go after that. That's good. That's good. So at least they don't feel left out. I myself went and sat in one of the other rooms so that Paul would not feel neglected by everyone that came to the reports. This is Trent. He is without question one of the smartest people that I know. What you will notice after his name is are some letters there, P-E-N-G and then Ph.D. right after that. So for the remainder of this presentation, and probably for the remainder of ScadaFest, I'm the only one allowed to refer to him as Trent. To everyone else, he will be Doctor. Absolutely, that is correct. I'm really looking forward to this presentation because this topic in particular has been the bane of my existence on multiple occasions. So I'm really looking forward to this. I am going to we'll take about 10 minutes after the presentation for Q&A right before lunchtime. And so I'm going to try and get to everyone. So if you don't mind just giving me just a second to get to you with the microphone so that we can record and capture the question. And in the event that we don't get to all the questions, please put your questions in the Whova app. And that way, that'll give us the ability to also capture, record, and respond to those from one of our experts. So without further ado, let's give a round of applause for Trent.
All right, thank you, Andrew. Is everybody ready to rumble? For a good cage match between some protocols that you probably most have heard of or maybe want to learn more about. So like Andrew said, this is the cage match of Modbus versus DNP3 versus Sparkplug B. So first, I'm going to do just a high-level overview of what the three different protocols are so you can understand them a little bit better in case you aren't familiar with all of them. How they work, what the pros and cons of each one are. Then I have a couple of data usage and CPU efficiency usage comparisons of the protocols. Just so you can kind of, some numbers. I'm a numbers guy, so you're going to see some numbers on the screen later on when I get to that part of the presentation. As well as some closing comments about maybe when you might want to choose which one. Some examples of this, you may be trying to replace some hardware and you get the chance to pick your new piece of hardware, which protocol it has on it, so you may be considering that. Or you may have a piece of hardware that supports multiple protocols. I'm seeing more and more of that these days, where one piece of PLC can talk Modbus, DNP3, MQTT, Sparkplug B all at the same time. So maybe you want to figure out which of these should I be using on this piece of hardware that I have. Or maybe I just want to try and optimize my system. Maybe I'm on a cellular network and data usage is very important to me. These are all factors you might want to consider when choosing a protocol to get the data from your field devices to your SCADA system. So I'm going to start with Modbus. So Modbus, most of you probably know, was developed by Modicon back in the late 70s, early 80s, which is now owned by Schneider Electric. It's a pull response style protocol. So you basically will have queries going out to a station for data and data coming back. So basically it asks for, I want this type of data starting at this point for this many registers is the very short version of what Modbus is, and then the station gives it back. So in a graphical sense, you have your master, which would be your SCADA system. VTScada would be running as your master in pretty much every application. We do offer the ability to pull data from VTScada via VPLC, but it's 99% of the time you're the master talking to the client, your remote RTU. We'll send a pull response saying, hey, I want 10 registers of data from the 40,000 register range. And then what'll happen, your client will respond with, here's the data, very short compact format messages, because it's very well defined what everything needs to be. So it's very data efficient. Three main variants that you probably have heard if you're familiar with Modbus. There's RTU, which was the original serial version of the protocol. OpenTCP is the modern version of the protocol. And then there's ASCII, which is basically RTU, but double the data because people wanted to see it pretty over the wire for some reason. Modern scanners and protocol scanners make that kind of redundant. So I don't really see any ASCII use anymore, but unless you have legacy hardware, that's what it supports. So like I said, ASCII is double the byte, or OpenTCP. The difference in that is it has a header with a packet identifier. That was one of the weaknesses of the RTU version of the protocol, is it would send out the station, the function code, which would be the data type and how many registers and a starting point, and the response would be the station, the function code, and the data. There's no unique identifier that the response you got was for the message you sent if you happen to be sending to the same station, same function code, and same number of registers. There was no clear way to distinguish the two responses. With OpenTCP, they added an identifying header as part of it, and there's a sequence number basically in there. That way you can actually mirror your responses back. So that's one of the improvements they made. And you might be wondering, well, RTU had a CRC, or cyclical redundancy check. That's just to verify that the message it sent to you was actually interpreted properly by you, because in the serial world, could be losses of data or bytes. So the idea was, in the RTU, before it sent the data, it would create the CRC calculating that these are the bytes sent you through this lookup table, CRC table, and then the client, and then the master station would get that, decode it, and make sure that the CRC matched what it received, so it knew it wasn't missing any bytes from back in the older technology that wasn't as always reliable on transmission. And like I said, ASCII, double the bytes of RTU, not really recommended to use unless it's your only choice. So what are the pros and cons of Modbus? Modbus is very lightweight. Like I said, it's very well structured and formatted. There's not really much overhead in the messages that go back and forth. It's pretty much all data, which makes it very easy to understand. I can look at a Wireshark trace and very quickly tell exactly what type of data is there and where it is in a matter of seconds, compared to some of these other protocols, which maybe let you do more things, but they're far more complicated. And the other thing Modbus does, it's not session-based. You can have multiple concurrent connections to the same PLC pulling data. This lets you get way more data back to your master system compared to other protocols where you have to wait and do serialized comms one at a time. You can do these in parallel. So if you have 10 different sets of registers you need to read that get distributed into what we call read locks in VTScada, you can pull all 10 simultaneously if you have 10 connections to that PLC that you can use. Where other protocols, you have to go wait for the first one to go, then the second one, then the third one. So Modbus can be very, very fast to get data back as well. The biggest con of Modbus is it doesn't include any timestamps of when events change. You have to pull it to know when something has changed. There's no trigger or timestamp variable defined within it that you know when that change occurred. I only know it's changed because I pulled and asked for it. As I mentioned earlier, with the initial implementation of RTU, if you sent out two requests in a row that would have basically the exact same response other than the data variables, you may not know which one was which. So that's why OpenTCP was added and is preferred for that reason, is you don't get the chance to misplace the data if you're on a poor network using serial RTU. So that's the basics of Modbus. The next protocol that most of you probably have heard about and seen is DNP3. It's the IEEE standard for electrical power system communications, called Distributed Network Protocol. The 3 is kind of like a version 3, but they didn't really want to include version numbers in it, but it's basically been a static standard at DNP3. I believe the last time the standard was updated was 2012. It's pretty much in a holding state at this point where they've said that this is it, we're not editing it anymore. The big difference is it's report by exception. So instead of the master system VTScada querying the RTU saying, hey, give me your data, the onus on data transmission is sent instead down to the RTU, where the RTU will have logic internally to it that says, hey, this data has changed, I'm going to tell my master system about it and push the data out. So the general architecture, like I said, you have the master system in the RTU, and this time, like I said, the RTU pushes out data to us. We're configured with an open listener port that will accept the data when it comes in from the RTU, and then we do have to send a confirmation response back so the RTU knows we have received the class data. That is part of the protocol, is that it expects to receive a confirm so we know we've been reported to. This is in case the communication network link is down, that is going to keep trying until it gets that confirmed from us. But DNP3 also lets you do 2 other kinds of polling. You can poll for exception. So in this case, you'll send a message down saying, hey, has any data changed? So instead of saying, like Modbus, we say, give me these registers no matter what. DNP3 has a poll for exception, says if any of the registers of these classes, and the terminology they use is classes, there's class 1, 2, and 3 within the protocol. Typically, you would configure them as different kinds of priorities of information you care about. And so you can query for the class data that way, and then it will say, hey, these values have changed. DNP3 also does support direct polling, where you can, just like Modbus, say, I want all the data from this analog input, from analog input 1 to analog input 10, just give it to me like Modbus style polling. That's not recommended, even though the protocol supports it, and you'll see why. You probably don't want to be doing that if you have the choice to use another protocol for that type of comms going forward. So what are the pros and cons of DNP3? The first pro for DNP3 is it does have timestamp formatted data. So the RTU typically has an internal running clock that can timestamp when the events trigger in the RTU itself. So if you need to know exactly when something happened, Modbus isn't going to probably do it for you. You're going to need something like DNP3 that can put the timestamp on the data of when that event happened. Like, when did that breaker trip open or close in electrical equipment? That's one of the common use cases for this kind of data. I need to know exactly when that breaker flipped open or shut. And the data does come in a defined order. The protocol specifies this is the order that the data has to be sent to us. That way we can sort properly in our historian. That's a very important part of the protocol. The other thing DNP3 do is it can contain what we call status flags or attributes on the data. So if DNP3 can also be used as an aggregator where you may be talking to one DNP3 station and it's talking to another station further downstream. So if it loses connection with the data downstream, it may still have its last known value for that station when you're talking to it, but it'll send us a status flag that says, hey, the guy downstream from me is offline. I'm not getting any more real updates from him. I still have his last known data, but I'm not communicating with him. So there's some extra information that you can get out of DNP3 in the status bits of there. And the other pro is, if configured properly, report by exception should be using less data than standard polling. And we'll see some mathematical examples of when these cases are true or not. Like I said, one of the downsides is the packets are much more complicated. Because it's a report by exception, it's only going to send the data that has changed to us. Every packet is going to look slightly different. We have to basically to process it, we have to go byte by byte, read a couple of bytes, go, okay, this is this type of data that they're sending us this time. This is how I have to process it. And then repeat that until we get to the end of the stream of data that's sent to us. Modbus, that's not the case. Modbus is just, here to here, really quick, like basically 2 lines of code, you can get all the data out of it. Here we have to loop through each set of data that comes into us. So it's much more slower and more CPU intensive. And it's also more difficult to configure. There's a lot more options in DNP3. Modbus, you just basically assign data to the registers in your PLC, you read those, set up those IO addresses in VTScada, data comes in, you're good to go. With DNP3, you have to decide which classes do I want which data points in, what kind of dead banding do I want on these IO for report by exception to me, because you can, some PLCs will let you set dead banding in them, say, I don't want to report every time maybe my water level changes by a few inches. I need it to be like, 6 inches before if you're looking wastewater, maybe 6 inches is the level of change that the operators really care about. They don't need to know if it's kind of bouncing up and down an inch or two, things like that. So there. And as you'll see, if you do decide to try to use standard style polling, you're going to use a lot more data than what Modbus does to do the same thing. So that's why it's not, I'm not saying you can't do it or that you shouldn't do it, because if that's maybe the only way to get the data, that is what it is. But if you have choices, it may not be your best choice. So next up is Sparkplug B. This is probably the newest of the protocols I'm talking about. DNP3 and Modbus have been around for quite a while. Sparkplug B is based on the MQ telemetry transport. It's exactly what it's called. It's a transport. It's not a protocol. MQTT is a framework of how to send messages, but there's no specification of what lives in the messages or how you should include certain types of information that it defines in its headers. So like I said, it says how things are sent and received, not a full payload. It's a publish-subscribe model. So basically, some members will subscribe to data to the central broker. Others will decide to publish data to the central broker. So there's 2 main messages, a publish message and a subscribe message that go back and forth. And it's typically report by exception, in that whoever is collecting the data decides when to send it out versus a query that basically because of the publish-subscribe model. When you subscribe to the broker for data, you can't really initiate a call further down and say, hey, give me the data. You're just saying, whenever somebody reports data about this, I want to hear about it. So what is Sparkplug B? It's a specification on top of MQT to actually turn it into a protocol. So it defines both what topics to use, which is kind of the namespace of addressing in there, and what the actual data in the messages should be formatted as. For those who are interested, it's actually Google protobufs is the containing structure within it and a defined payload within those. And this allows the devices to communicate via a common framework, because the initial issue with MQTT is, yes, you can implement it, but then every device needs to know the same language in order to interpret the data that's coming to it. That's what Sparkplug B has done for MQTT. It has defined the language, that way everybody can talk to each other and understand what they're saying, instead of just sending messages back and forth kind of blindly. And the other thing that Sparkplug B does is it allows for configuration changes of the end device to be understood by the host. I'm going to give an example of this here in a minute. And data delivery is initiated by the edge of network devices, so it's report by exception. So your field device is going to send you the data, and then your host system, your SCADA system, is going to consume it. I'm just going to flip over. Yeah, I got it. Here. Flip over to my application. So I got to connect to the. So I have. Some of you may notice there's a little Raspberry Pi device sitting on the front here. It's broadcasting a Wi-Fi network that I'm going to connect to and running a broker on it already. So I'm just going to show you how easy it is to create tags in Sparkplug B and VTScada. So I should be connected to the device now. So if I've already pre-configured my port to talk to the broker. All I need to do is go to New Child, create an MQTT client driver, call it a Sparkplug B driver. If I go to Connection tab, I can choose what protocol I want to use. Sparkplug B is what I want to use because that's what that's talking. And then there's this little checkbox down here, automatic tag creation. Basically, you can choose to have tags automatically created in VTScada whenever we get what they call birth information from the device. So I'm going to click OK, and here in a couple seconds, we should start, tags start showing up. So that device is sending me data. I've automatically got all my tags in VTScada that device is configured for. That's one of the powers of the MQTT Sparkplug B, is realistically, you only have to configure your edge device. VTScada will absorb all that data and automatically create all your I/O tags for you in a matter of seconds. I didn't configure anything. And the beauty of this is this works with our sites page. So say you wanted to test out if the links are all working as expected. I can go to the sites page. I know it may be a little hard to see. There's a couple LEDs. I can turn the LEDs on or off. So the red LED turns on. I can turn it off. I can issue control from it already. And there's a little buzzer most of you hopefully will be able to hear when I press OK here. So I'm talking back and forth with my device, already controlling in VTScada in a matter of seconds. Right? It's very quick and easy to get up and working and testing. Very, very powerful what the protocol allows you to do with that. So if we go back here, so I just wanted to give you an example of how user-friendly parts of this protocol are. So like I was saying, the heart of Sparkplug B is this central broker, right? This is where everybody's talking to. So right now, everybody only has to, the other thing everybody needs is only one data connection. You're only ever talking to the broker. You don't need to connect from your SCADA host to devices A, B, and C. You just need to connect to the broker, and you'll get the data from all three devices. That can be a good thing. It could be a bad thing, because if you lose that link, suddenly you lose data from all three devices. So there's pros and cons depending on your situation of this. Like I said, from an IT point of view, much easier to maintain only one link. You only need one set of certificate, perhaps on the one link, talking to your broker to get all your data from all your field devices throughout the world. But at the same time, if that link goes down, you're suddenly blind to everything until you fix it. And that's the other advantage for these devices too, is they only need to maintain one link to the broker as well. The other thing I haven't shown on here, but you may have a business unit that also cares a little bit about your data. They may only want a subset of the information that you're pulling into your SCADA system. They can also connect to the broker and get the data directly from here without impacting your SCADA system at all. That's one of the other things that MQTT does, being a publish-subscribe model, is that there's no extra work on your end device to tell your business system that there's data there. They're still just sending data to the broker. It's your broker that's doing all this for you. So it's more of a distributed model than a direct connection model is kind of one of the big takeaways about what MQTT and Sparkplug B are typically going to be used for. So yeah, like I said, distributed model. Only one connection needed. Sparkplug B does include timestamps as part of its data, so you can use it similar to DNP3 to get timestamp data back from your devices. This is going to be, it's not a strict requirement, but most manufacturers that I've seen include it. It's going to be up to your edge device how you can configure it, but it's feasible to do with the protocol. And like I said, it's a report by exception, and you only have to configure it on the remote devices. As you saw, I pulled in a bunch of data. My tags were labeled LED on and off. The LEDs turned on and off. The speaker buzzed when I turned it on. So in that sense, instead of configuring everything in your RTU programming software and then configuring it all again in your SCADA software, it's quicker and easier. We do have other ways to do this with other protocols, such as some of you may have seen the Rockwell driver. We do tag imports from other protocols. I'm expanding that, but that's kind of one of the features that's directly involved with this. But like I said, the same pro of being a single connection can also be a con, depending on how critical the data is. The other downside of Sparkplug B is you have no way to pull directly in the protocol. DNP3 does let you do what we call integrity pulls or direct pulling if you really need to for some reason. You can send down an integrity poll, get all the data for the station, then go do report by exception afterwards. There is no ability built in the protocol to do it. Some devices support what they call a rebirth command that will send you everything, but not everybody supports it. So it's not actually defined in the protocol that it'll work, but so that's one of the things to be aware of, is that you can't say, hey, I want the data right now from Sparkplug B MQTT. You are relying on the end device to give you the data. So I'm going to do some data efficiency comparisons, just kind of a high overview, a little more details about the protocol. So for the Modbus, I'm going to do my example using OpenTCP. It's my preferred version of the protocol because of the sequencing and packet matching. So because of this, you get 600 bytes followed by your data bytes. Basic math is there's 12 bytes per request that go out if you're reading 16-bit integer register data. And then you get 9 bytes of overhead plus 2 bytes per register coming back. So you get 21 plus 2 bytes per register net traffic per polling cycle. And for all the examples here, I'm going to assume my Modbus is going to be polling once a second, just as the rate I've chosen, just for comparison between the different cases. For DNP3, there's 4 different cases that I'm going to consider because the protocol lets you do a lot more things. There's more ways you can configure it. The first is do report by exception only and include the timestamp of when things happen. So you get 25 bytes, basically 40 bytes of overhead, 25 on the response coming, or the unsolicited response coming to you, plus your 15-byte response back to the RTU saying, hey, I got your message, and then 10 bytes per data point that's included in the message. You can also do report by exception without time. Maybe you don't need to know exactly when it happened, you just need to know when it was reported to you as an operator. So you can cut down some of your data load. Only difference here is you're saving the 6 bytes of time that are being sent back and forth. Third example is doing direct polling. This is just merely here just to show why you may not want to set this up if you have a choice. So the requests are 20 bytes going down, and it's 22 plus 3 bytes per data coming back. And then the last one is poll for exception. Basically, you can poll for class 1, 2, or 3. You can choose which classes you want to poll for. And in my example, if you're polling for exception, I'm assuming you're going to want time coming back with it. You're going to want to know when that changed in the RTU. You're not going to wait till you poll for exception to actually timestamp it. That doesn't really make much logical sense. So poll for exception, I'm assuming you want time coming back with you. So the requests are 15 bytes plus 3 per class, so anywhere from 18 to 24 bytes. And then the responses are 25 bytes plus 10 per data, just like the other responses coming in, if there's data for you. Otherwise, there's a 17-byte message saying, hey, I got your message, but there's nothing for me to tell you. And then for Sparkplug B, I just picked an arbitrary topic. What you'll see is there's 1 byte of overhead in the topic namespace. Parts of this are not changeable. The FPB v1.0, that is a fixed part of the standard. D-data is also fixed part of standard, but the group 1, node 1, and dev 1 are all components that you can change within the MQTT standard to meet your needs. That's how you kind of identify each piece of equipment you might have out in the field, is through those 3 topics. So like I said, in my case, it's going to be 31 bytes sent, and there's also an additional 4 overhead bytes sent with every message on top of the topic length. And then data is reported by metrics, and there's 2 ways they can be reported. They can be reported by name or by alias. I am doing alias, that's what's recommended because it's far less data in the protocol. So anytime you're reporting metrics, there's going to be 9 overhead bytes to define how many metrics are coming with you, and then there's 15 bytes per metric that come in. 7 of those bytes are time, so you may have an option to turn those off if that matters. I'm assuming time's coming in, and that data is published when it's changed only. So you have a net mathematical relationship of 58 base bytes and then 15 extra bytes for every metric that's being sent to you. Just for those that like math and understanding what's going on in the scenes, this is kind of how the protocols work. So I did a handful of case studies of how much data does each of these use in there. So my first case study was, I have a single value that changes once a minute. So with Modbus, if I'm polling once a second, I'm going to use 1,380 bytes. That's going to be fixed. That's always going to be the case for Modbus reading one value once a second per minute. That's never going to change. The DNP3 direct polling uses 2,700 bytes. Almost double Modbus doing the exact same thing. This is why, if data efficiency matters to you, you probably don't want to do direct polling with DNP3, especially if you have Modbus as an option available to you for the same data. So if you do unsolicited data, we're only going to use 44 bytes. We only get one message sent to us, one response sent back because the data only changed once. That's great. That's only 3% of what Modbus does. That's exactly what I was talking about earlier. If you have very infrequent changing data, you can save a lot of bandwidth with these report by exception protocols. And then if you include timestamps, you're still only 4%, not a big deal. And if you do, the other option is you can do exception polling. Say you poll for exception, but you do that every 10 seconds because you know you're going to get your timestamps backfilled instead of polling for exceptions every second. That's going to use about 264 bytes, 20% of what Modbus is doing. And then, like I said, maybe you want to poll for exceptions every second. So you're not polling all your entire RTU every second, but just say, hey, has anything changed? Has anything changed? Has anything changed? We have some large customers that do this. This is because they want to see the changes really quick on their operator screens, but they don't want to be querying the whole thing. That's using more data than Modbus, 180% of Modbus because of all the overhead back and forth. Because each DNP3 message is actually larger than Modbus for a single value, this comes into play. So if you only care about one value, you're probably actually better direct polling than poll for exception. But and then Sparkplug B, we get one message sent to us, 73 bytes, 5% of Modbus. So as you can see, there's kind of two extremes. The DNP3 direct polling, which is the worst, and then DNP3 is also the best if you configure it correctly, which is what I was saying before. DNP3 can be complicated to get set up correctly for your system depending on the type of data you're using. So what happens if we say, instead of changing once a minute, the single value changes every 10 seconds? Modbus still 1,380 bytes, DNP3 direct polling still 2,700 bytes. DNP3 unsolicited data, we're going to get 6 messages sent to us. We're up to 20% of Modbus. So as you can see, the more frequent the data comes in, the relationship starts to change. So yeah, 19, 22%. Exception polling, still 26% of Modbus when we're doing it for every 10 seconds. When we do it every second, still 186%. Sparkplug B starts climbing up as well, 32% of Modbus now. So as you can see, these percentages for the report by exceptions are starting to grow. We're still at DNP3 unsolicited being the least amount of data for a single data point, and DNP3 direct polling still being the most, but we're starting to see some convergence. If we go to that single value that we're polling changing every single second, Modbus, DNP3 direct polling, they don't change. DNP3 unsolicited data, though, now we see, we're almost effectively exactly where direct polling was at this point because it's sending that unsolicited data every second. So this is where suddenly, well, maybe if I have fast-changing data, I'm going to start going back to Modbus. The exception polling, every 10 seconds, you still end up all your data that you can backfill, and you actually still save some data that way. Exception polling every second gets even worse again. And Sparkplug B also gets worse than Modbus once you start sending data every second for the same point. So you go from a low of DNP3 still being potentially the best in this case because you can do the report by exception polling every so frequently if you don't need it immediately to your operator. But then you can go with Sparkplug B, which was one of the better ones in the first use case of once a minute, now being the absolute worst when it's changing every second. So you'll see some people tout these protocols are really good or really data efficient. That's in certain use cases. So now, one value changing that you're pulling for all the time from a single station, that's not a truly realistic scenario. It's a good test scenario to compare protocols. Something that's a little closer is you may have 10 values from a PLC you're reading, a set of registers about a pump or something like that, all grouped together that are changing, and say they change every 10 seconds as a group. This is to simplify some of the math for the report by exceptions. In this case, if we're reading 10 values instead of 1, we're up to 24 bytes instead of 1380 bytes now. So not quite double to read 10 times the amount of data. DNP3 direct polling, though, is quite a bit higher, 2,700 to 4,300. It's gone up there. It's still, almost double what Modbus is to do the same thing. And then DNP3 unsolicited data, you down to about using 20% of what Modbus is if they change as a group, so you're only getting one packet sent to you with everything in it every 10 seconds. Or if you have timestamps, 34%. Exception polling, still, about 36% of Modbus. Exception polling every second, a little bit more than Modbus. And then Sparkplug B is about 85% of Modbus when you're doing 10 values changing every second. and as a group. So like I said, this is actually sending one message with all 10 values in it every 10 seconds, not a smattering of messages. We'll see the math on that later, but like I said, DNP3 can still be the lowest and the highest all at the same time again. So what happens if this block of data is changing every second? How does this math work out for us? Modbus, DNP3 direct are still at the same points. DNP3 unsolicited data is now actually worse than DNP3, without timestamps is worse than DNP3 direct polling, and with timestamps is even worse. So we're getting large chunks of data every second with a bunch of information in it that's relatively redundant at this point because it's coming in so fast with extra overhead in it that, I'm looking at this, I'm like, if I have the choice, I'm going to want to use Modbus for this type of data, not DNP3 just on a data efficiency point of view. And you'll see even further why from a CPU efficiency point of view as well within VTScada. So exception polling every 10 seconds. Still quite a bit of data coming in. Exception polling every second is really bad. Sparkplug B, though, is where things grow exponentially. We end up now using 500% of Modbus, 5 times the data, to get the exact same thing if you're publishing a lot of data very frequently with MQTT Sparkplug B. So that's why it's very important to understand what type of data you're sending over these protocols as to which one may be the most data efficient if that's something that's critical to you. If you're using cellular networks to get data from your remote sites, understanding the relationships between the amount of data published per data change is important for that if that's one of your driving costs. The other thing I want to talk about was the effort to code a packet with a single value polling as fast as possible. So I hooked up, we have some devices in our lab that I was hooking up to and talking to and just seeing how much data can I go through and bring in, and how much effort does that take on the CPU within VTScada. This can be actually done within VTScada using the profiler tool. So that's where all the test data comes from. So I have a Modbus PLC in the lab. It's a Delta AS332P in the lab that I was talking to. And I just set single value, just one register, polling as fast as I can. You can do that in VTScada by setting your scan rate to 0. That just means you're going to pull, the moment you're done polling, you're going to do it again and again. I could get about roughly 10,000 cycles in a minute. That used about 8 seconds of the CPU during that time. DNP3 had to go through it. The device in the lab has a serial converter in it, so number of cycles aren't really necessarily comparable in this case because there were some different mediums in between, but what you can really look at is the what I call the effort per cycle, because everything else in my application was static. The only thing I changed was which driver was talking to a single register to get data back and forth, and these were static registers outside of Sparkplug B. Because Sparkplug B, you have to change the data for the report. That's just a limitation of what it does. But for DNP3, the fact that it's on order of magnitude in cycles isn't necessarily indicative if you had TCP connections to both. But what I found was it took 8 times the CPU power to decode that packet. Because like I said, Modbus, we can decode the packet, basically 2 lines of code. We know it's a series of data in an ordered manner that we can just break out into an array and pass on to the rest of the system. Like I said, with DNP3, we have to read, for each data byte, we have to read, what type of data is it? Is it an analog? Is it a digital? Does it have status flags? Basically the group and variation numbers that come in the packet. And then based on that, we have to read the next X number of bytes and interpret them the right way. And then we repeat that process for each data that comes in. So that's where you can see the differences here. And Sparkplug B, like I said, I was publishing as frequently as it could, but not as controllable as direct polling for the other 2 examples. And the other caveat is that, yes, the data was changing, so there was a little bit more historian load. So the 12 times is probably more like 7 or 8, but it's still, the point is it's still far more complicated to decode an MQTT payload, Sparkplug B payload, than it is to do a Modbus payload. So if you find that you're being CPU bound on things, then maybe a lighter weight protocol, if the other factors that we've discussed don't matter, that might come into play. And then I said, well, how does this scale if I try and do this for packets with 10 values? My Sparkplug B device didn't have that, but so I just limited this to Modbus and DNP3. As you see in the Modbus, I'm still getting roughly the same amount of data back from the PLC, about 10,000 cycles in a minute when I'm pulling it as fast as I can, and uses about 9.5 seconds of the CPU. DNP3 still, like I said, there was a serial converter partway, so the cycle count isn't comparable, but you can still look at the effort level of, if you take the time per cycles, DNP3 now is about 10 times more expensive because, like I said, in the one case, we didn't really have to, we only went through the loop once. We had the single value, we had to decode what type it was. do the rest of the math on the packet from that there. When you start doing it 10 times, you're going through that loop 10 times, and as you can see, looping through things actually grows your time in between. So that's another example of the CPU efficiency comparison there. So that's another case where you may want to pick, like I said, depending on if you're CPU bound, in some cases, a protocol may help alleviate that or may help explain why you're seeing certain CPU behaviors. So from here, I have a little bit of time. Like I said, I did the Sparkplug demo in the app already to show how easy it is to get these tags in the VTScada. I do have a bit of time that we can look at some of the other, I created driver tags of every type in my application. So the DNP3 driver, just to kind of relate some of the things I was talking to how you might configure it in VTScada. So your communications is where you set up where you're talking to your timeouts, that kind of information. The main tab I'm mostly interested in is the polling options tab. So this is where you can configure which classes you want to poll for in those poll for exceptions I was talking about. This tab up here kind of controls that. So you can say, do I want to only poll for classes 2 and 3? I would disable class 1. How frequently do I want to poll for exceptions to my RTU? That's what this check RTU interval is. The periodic integrity poll is, like I said, is where you say maybe once a day I want to get all the data from my RTU. I think that's 86. So you set up something like that. So once a day, I query the RTU, say, hey, give me everything you have, make sure I didn't miss anything along the way. So you can do it that way. And like I said, typically you're going to want to enable unsolicited data if you're trying to minimize your data usage via DNP3, as we saw in the examples I was going through. So this checkbox here, and you can disable certain class responses. So maybe you only want unsolicited data for class 3. You can disable classes 1 and 2. So there's a lot of configuration you can do with DNP3, which is why I mentioned it. It's far more complicated to configure both at the RTU and in VTScada than what Modbus is. Modbus, for comparison, if I bring up that config folder, you have an options tab that says which version of Modbus am I going to use, serial RTU, serial ASCII, embedded TCP, which is basically serial RTU, but you're using it over a TCP connection, or Open Modbus TCP. There's some, depending on the manufacturer, if you're doing floats and doubles, the byte ordering you may have to change around. It's not in the standard which way to put the order on that, so the options are there. This is pretty much all you have to do. Then you go to Communications tab, you just set up what station am I talking to and some timeout, that's it. There's not any other real decisions when you're setting up Modbus. It's very straightforward and simple. And then as we saw with Sparkplug, once you set up for Sparkplug and bring in tags, everything populates for you automatically. So that's kind of another example of DNP3, yes, more powerful, you can do a lot more with it, but you can also shoot yourself in the foot with it at the same time if you're doing some of these powerful things, if you're not careful. There's also a relatively new feature in VTScada called DNP3 default no scan. If you've used our DNP3 driver in the past, you probably got tired of typing :NS after everything if you only wanted unsolicited data coming in. Because previously, we used to default to always polling unless you put in :NS. Well, as of 12.1.39, we now have a new setting that in all new applications, this will be true. You'll have to, if you want this in your existing applications, you'll have to come in and set it, that you can make it so the addressing scheme now defaults to that. If you just type in 30/1/0, it will now default to do no scan instead of direct polling. If you want to have maybe some addresses direct poll, we now have a new address specifier at the end. It's called :DR. Actually, you'll probably see that if I put a IO tag under here. So what you see, we also have an address assist for the DNP3 driver. So in the address assist now, we have a direct poll checkbox. So as you see, address we create automatically will have the NS on it. If I want to direct poll it instead, I can check that box, turn it off. I can pick which kind of group it is if you don't know your groups in DNP3 off the top of your head. Some people have these memorized if you use it a lot. Others of us look it up on the table every time we do it. I know analogs are 30, analog outputs are 40. Binaries are 1 and 10. So you can configure exactly if you know it's an analog input and I want all variations, index 0, there you go. So yeah, so you don't have to type in the NS, and the address assist now puts in the NS for you, just so it's also clear to you that you know that you're not going to be scanning that address, because it is a slight change in behavior, but it's one that a lot of customers have been asking for because they get tired of typing :NS on all their addresses on this driver. So it is there now. So that, like I said, that's one of the newer features that has recently gone in for this. So it's Modbus, DNP3, Sparkplug B. I guess the other thing to note about Sparkplug B, other option you can do, if I just delete my driver, I'm going to recreate a new driver to show. Maybe you don't want, you saw how I brought in a bunch of tags automatically. Maybe you only need a subset of the tags. What you can do is, if I create a new MQT client driver here, Sparkplug B driver, if I uncheck the automatic tag creation, I can hit apply, hit OK, and then I'll have the driver here, but as you see, no tags coming in. The other option you can do, though, is we're still scraping all that data that we use to create the tags. We're still storing all that information. I can go here, click this import button. Once the driver connects there, where's my Wi-Fi still? Oh, yeah, still there. Should let me import these directly. Yeah, here we go. I just have to wait for the data to come in from the broker. Little time lag there, but now I can come in here and I can click Show Children. I can pick exactly which of those tags I care about. Maybe I don't, let me just make this a bit bigger. Maybe I don't care about the reboot command. Maybe I don't want that tag coming in. I can uncheck that tag and not bring it in, or control next server. That's not something I'm ever going to use. I'm always going to want to be talking to it from my server. I don't want to tell it to move along. Or maybe I don't really care about reading the hardware serial version, because these would be I/O points that you're using that maybe they contain information you don't care about. So you can actually come in here and filter down to what you just care about. Click OK, and then all the tags I left checked now come in. So same as before, I can come back to my sites page and start controlling the unit I have here in the front. I can turn the buzzer on. You guys can all kind of hear that. The other thing I didn't show is I can press the button. There's a button here on the unit. I can press it. When I'm down, you can see the button is now on and off, and the press counter keeps going up. I know it's a little small on the screen, but as you can see, the interactive data, that's how quick and easy it is to start interacting with Sparkplug B things. But as you saw, if you're using it with rapidly changing data, you could be using a lot more bandwidth than you may be realizing. Yeah, so if I go back to the presentation, so like I said, this kind of brings me to a summary, kind of everything I talked about here this morning. First, Modbus, it's the lightest CPU load per packet. It has the best data usage if you have a lot of data changing frequently and you want to know about it quickly. Like tens or hundreds of registers changing, in the second range. Modbus is probably what you want to use. Like I said, the only downside, it doesn't include the exact timestamping of when the event occurred. So like I said, for DNP3, if you need to know exactly when the event occurred, like when that breaker tripped open or tripped closed, you're going to want to use something like DNP3 that has that timestamp information that the RTU can log that and send that to you. Like I said, DNP3 can be the lightest depending on how frequently your data is changing. If you have a bunch of digitals that rarely change, DNP3 is probably a better bet than pulling them over and over again with Modbus, because if the value's not changed, there's no point asking the RTU, hey, have you changed, have you changed, have you changed? So like I said, it's very use case dependent. There's no one global, this protocol is the best. That doesn't exist. It's sort of use case dependent as to which one you may want to use. And like I said, the other thing about DNP3 is, actually I'll go back to the config folder. No, it's not necessarily going to be a tie. It's going to be in which situation. There's no. I can't say yes. Always use Modbus, because if you need timestamps, you're dead in the water because you don't have timestamps in Modbus, right? But if you need timestamps, but your data is always changing, you're not going to maybe. DNP3 is probably where you're going to end up, but maybe if you have some subsets of the data that you can pull a different way, like I said, some newer PLCs let you talk to it with different protocols. You can assign the stuff that changes frequently. Let me bring that up, presentation mode. Not beginning. So like I said, yeah, if you have a bunch of analogs that are changing frequently that you don't need direct timestamp information, say like the level of your lake, it's going to fluctuate somewhat regular, level of a well. You maybe don't need to know exactly when that level changed, but you need to know relatively soon within it. You're probably going to read analog data like that with Modbus. If you have these digitals like a breaker that almost never trips, but you need to know exactly when it trips, you're going to assign that to DNP3. So that way you get the timestamp when that data changed, you get that sent to you. And like I said, you can set that report by exception, so you're not wasting bandwidth asking, hey, have you changed? Hey, have you changed? You just get told, yes, it's changed. And like I said, Sparkplug B, the big advantage of Sparkplug B is when you have multiple consumers of the data. So if it's just your SCADA system holding it, that still works, because in that case, like I said, you only need to maintain that one connection to your broker. You don't need to link to devices A, B, C, and D. Like we saw in the diagram, you only need the link to the broker. Everybody else also only needs to maintain one link. You don't need, n links to n devices. Like if you had, say, a SCADA system, an operating, and a business system that didn't want to maybe link via SCADA, which I believe Devraj was talking about in one of the other rooms, how to get data out of VTScada. If you didn't want to do it that way, you would have to have multiple links from each of your devices to your different networks. So that's one of the powers of MQTT and Sparkplug B, is that you can have multiple consumers of the end data, and each member of the chain only needs one communication link. So it makes distributing data like that much more powerful, much less bandwidth, because you're only sending it once, not n times. And like I said, but like I said, there's also the downside to that single connection, is that if you lose it, you're suddenly blind to everything, not just that one RTU, where if you had a direct connection to each RTU, you lose one link. Well, yeah, it's never great to lose a link, but at least you're only losing that one RTU, not your whole system. So that's sort of the other caveat of things to be aware of when working with this. So is there any... So yeah, that's concludes where I'm at in terms of the overview. If there's any kind of more directed questions.
Hi, I have several questions, but I'll share the mic. One of my first questions is about, do any of the brokers for Sparkplug B support any form of like failover redundancy?
Yeah, the protocol supports that itself. I didn't go into that in great detail. The protocol defines that you would have a redundant broker, so basically two brokers would exist in your system. And what the SCADA host does is it publishes to the broker it's currently listening to an ID that says, yes, I'm online. So that way your end devices know that that's the broker I want to talk to. But what you set up in your end device is basically have an IP list of where your different brokers are. And what's supposed to happen is if it's connected to a broker and it doesn't see the host living, it's supposed to move to the next one, check for the host. If it's there, I'll stick here and start sending data and keep cycling through. That can be configured in VTScada using the driver mux chains. That basically we would actually listen on all the brokers. So that way once somebody gets on one, you can have redundancy there. It's a little more complicated setup, but it definitely works within VTScada to do that. So you basically set up two brokers, probably ideally not in the same room, obviously like for redundancy purposes, but yes, you can do redundancy with it. It's just a little slightly more complicated setup, but via the driver mux would be how you'd work with it in VTScada, just like you would do redundancy to other types of PLCs within VTScada.
Stupid question. On DNP3, we've certainly run into an instance where one of the manufacturers of hardware says, yes, we support DNP3, but they don't allow report by exception because they can't open a TCP IP port at the device level. We have another instance where we know the manufacturer's implementation of DNP3 doesn't write the message back to the hardware and effectively clear the events in the hardware device. How frequently do you run into issues, or do you run into issues more frequently with DNP3 than other hardware?
I would say yes, DNP. Because of the complexity of the protocol, you tend to run into more poor implementations by different vendors. You see a little of that with Sparkplug B2 sometimes. And the Sparkplug B specification had some ambiguity in places that some people viewed it one way. We went a different route. We've had to come back and course correct on that. So that is one of the downsides to these more complicated protocols. Yes, they're more powerful. You can do a lot more with them, but you tend to get a little bit more ambiguity depending on how people interpret spec or what subset they do. Because DNP3 does have different level subsets within it. as well.
So Pat's question was a stupid question. Mine is less stupid, but it might even go kind of with what Hudson was asking. So no, on the MQTT side, is the timestamp based on the broker's timestamp?
No,
the devices.
The device would send the timestamp to the broker, and then there's two timestamps technically, actually. The device can include the timestamp when it sends the data to the broker, and the broker can also timestamp when it sends it to you. So there are two different timestamps in that we use the device level timestamp if it's there, because that's typically what you care about in your SCADA system. When did that change, not when was I told about it. But there are two different levels of timestamping within it.
I'll just stick to the Sparkplug B for a second. Do the brokers support a segregated network to where the devices are on one subnet and the SCADA servers are on a completely different subnet?
I'm not sure. I don't know the answer to that, actually. I've only ever configured testing my network. I understand what you're trying to do. You're always talking, yeah, you would almost need the broker to have two network interface cards and both talk to the same set of data. That's kind of a broker. We don't supply a broker, so yeah.
Right now, we kind of poll our devices with Modbus, but then we're going to send our data out as an MQTT packet. If we have those timestamps in there, how can we set up like a history in VTScada to read the timestamps in our MQTT packet? I don't know does that make sense? So we'll send out a message over a meter connection maybe once every 5 minutes.
Yeah.
But we'll poll this device maybe once every 5 seconds. So we'll have a lot of data stored up with timestamps, and then it all gets sent over as one big packet.
Yep.
Any chance that, if there's a data point with a timestamp assigned to it, that VTScada can read that and backfill a history?
Yes, yeah. VTScada does that. Some Sparkplug B devices do that already, where they send multiple, they call them metrics. You'll see the same metric repeated with different timestamps, and we'll scrape all that in and stick it in. It is doable. Even if you're using MQTT in general, like with JSON or something else, if you write your own, you'd have to write your own custom encoder or decoder for that.
Right.
But there are help documentation on how to do that. But yes, it is definitely possible to scrape those timestamps and value pairs and put them in the historian.
Aha. Thank you.
So, excuse my ignorance, but you say broker, right? Like
Yeah.
that's a server or that's something somewhere, and what do you install on that? Like what's the, you know what I mean? Like
a broker, it's an independent from VTScada piece of software. Mosquito is one, HiveMQ is another that you can purchase. You basically run it typically, I think it's a Linux box typically. Most of the ones I've seen, you can run them on Windows too. Like I said, I'm running one on the Raspberry Pi on the desk up here, on Linux, for the demonstration purposes here. It's a third-party component you'd have to purchase. Some are free. There are free ones, but yeah.
Okay, that's what I was.
You can just hand it to us.
I might be mistaken here, but doesn't DNP3 have a minimum time between unsolicited reports?
I'm trying to think if it might be configurable within the specification, but they're configurable, yeah. Because I understand you probably don't want to. You could probably configure that, but not. And that's kind of the Pat's point. Not every manufacturer puts in all the configuration tools that you need. But yeah, we can't control that in VTScada. You have to configure that in your RTU as well.
I kind of have a comment and maybe a question in there that he may or may not have an answer, but we've implemented a MQTT solution with wastewater pump stations recently. We started out, just kind of information, your whole presentation is interesting because 14 years ago we put in a Verizon private network, cellular private network, and our concern was data. And I actually pulled up our 1 gig per month of data is $25 a month. So we had 7 remote sites at each one, $25 a month. So we started out looking at Modbus, and our data was too high, and you actually had to bump up to almost like a 10 gig a month plan, more like $80 a month on private networking. So we ultimately used a Red Lion RAM cell modem that has what I refer to as automation in it, which is basically report by exception. So you implemented that in the cell modem. It talked Modbus TCP to the PLC, report by exception back to the admin building, and that worked. We're doing 1 gig a month. So when you take all what you did, I've got dollars and cents to it, that we could do that for $25 a month per station on cellular. And without that, we couldn't do it. So now you fast forward 14 years and that modem's obsolete. So we started using a Red Lion DA50 using MQTT. And we've got that implemented. And you talked about the broker. We came up with Teltonica, a RUT X10, RUT X10 is what we're using for our MQTT broker. So it's just a piece of hardware, real easy, inexpensive, and it works great. So that's what we're doing for our broker. So we have the Red Lion talking Modbus TCP to the PLC, and then the Red Lion is configured MQTT back to
the broker,
that RUT X10. And then we've got another Red Lion that's basically doing that same MQTT to that broker. And then our SCADA software, any of our HMIs in the plant can talk to the Red Lion to grab that data. So one of the things I'm looking at, that location doesn't have VTScada, but we want to upgrade that to VTScada. So kind of keeping that in mind. Yeah, but the part I'm kind of curious about now is we go in Red Lion and we configure MQTT. That's what we pick. There is a Sparkplug option there, but we're not using that. So now I've got the MQTT broker, everything flows back, but you're referencing a Sparkplug and your driver referencing a Sparkplug. And I'm kind of wondering, should we really be looking at Sparkplug if we want VTScada to talk right to that broker? I'm just kind of wondering, is there something there that I'm missing? But we've converted part of our system over to MQTT. Part of it still has the old RAM modems, but we're keeping the data well within the 1 gig per month. So when you go back to everything you presented, we've switched it and we're keeping within our data limits. We're trying. But I guess I'm kind of curious now what the difference between what we're doing is MQTT versus they have a separate, in that same section of the Red Lion software, they have one called Sparkplug. So do you know, are there different versions of MQTT or?
Well, like what I mentioned earlier, MQTT is mainly just a transport. You can put anything in it, which is why in our driver, if I bring that back up, this is kind of a good question. You can actually do both over the same broker. You don't need separate brokers for Sparkplug B versus MQTT. You can do JSON-based packets and Sparkplug B all in the same broker. The broker doesn't care. The broker does only MQTT. Sparkplug B is really just a specification to give you better naming structures on your topics. So what you'll see, if I bring up an IO tag, and if you've configured part there, like basically Sparkplug B defines what basically the topic has to be. Topic's part of MQTT. Sparkplug B says this is how you name it. So that way other people understand what your data is. And then this is basically what we call the metric, the piece of information that's embedded within that topic that I care about. You can do this with JSON structures. Like, do you know what kind of data format the MQTT is currently? Is it JSON packets probably, or?
I don't know. Yeah, I'm not sure.
Yeah. So basically the point is, using a broker, you can do both on the same one. Like I said, Sparkplug B is just become the de facto, in a way, protocol over MQTT because MQTT was undefined in terms of what you put as the payload in the message. Which is why if I go back to the driver itself, even though
Probably we should be looking at implementing Sparkplug maybe to be more standard as well.
Yes, Sparkplug B would probably be the quick and easy one, but maybe that, depending on the overhead that Sparkplug has versus the structure that the Red Lion MQTT that you're currently using is, you may find that using JSON, or in this case, like I said, like Dave and I discussed, you can create custom encoders, decoders for your exact use case within the driver, and that's because MQTT is not defined. There's one basically part of MQTT, and that's why it's called a transport, not a protocol. It tells you how to send data, but it doesn't force you to send the payload part there. It gives you the headers and some other pieces of information, but not the actual payload definition. That's where Sparkplug B came in.
For your use cases that you said, hey, here's your cycle load.
Yeah.
Here, do you have a case where you've got maybe 30 tags that almost never change, and then 3 tags that change every second?
I haven't done. I can do that pretty quick. I don't have that here with me. I was trying to show the processing load because I'm trying to isolate the historian part of it because I was trying to keep it constant. So you were just looking at the raw processing portion of the payload, not all the downstream changes, which is why the MQTT example is a little has a bit of an asterisk next to it because the data had to change for it to be sent for me to process it. But no, I think that could pretty easily be done. It actually, the tool to do most of this, if you have a static setup, is within the source debugger. We have what we call the profiler, which lets you see how heavy things are. So if you have just like a blank page, single driver, single IO tag, or 30 IO tags that you're reading, you can run the profiler for a fixed amount of time and just compare. There's a scheduler lock kind of term which shows you how much CPU VTScada is using, so you can kind of see the differences there. It's something you could probably experiment with. You got me a bit curious too. I imagine 3 changing will be heavier than 30 static just because of all the historian writes and everything else that's going on in the system. I was trying to eliminate that to keep it cleaner to just the protocol level portion of it.
Yeah. Yeah, I was curious because I would say my typical situation where I've got a bunch of tags that are set points or they're run statuses and they may change every 5 minutes.
Yeah, which would be closer to what I was showing because my data was static when I was doing those use cases.
Yeah, but then you have your speed that's constantly jiggling just a little bit.
Yeah.
Anyways, oh shoot, I forgot my other question.
And I'm not really sure if, probably a lot of people might have this question too, but I was just wondering, could you come and sign my baseball card?
Sure.
Thanks. Could you come and sign mine first? That'd be great.
Yeah, I'll come sign it.
Great presentation.
So, front or back?
Wherever.
On the clouds.
Well, he can sign and answer a question at the same time.
Yeah. Any other questions?
As far, I have 2 questions. One, as far as if you're going to backfill. Okay, sorry. Anyway, if you're going to backfill the data you need with time step data with MQTT, how do you set the clock in the remote device? I know DNP3 supports that.
Yeah, DNP3, there is no time sync functionality in Sparkplug B. It would be up to the manufacturer to have the internal clock syncing. Probably via the broker, maybe, if it does it. There's nothing in VTScada that configure to tell it to sync the clock.
Yeah, but in the okay, I mean that's because it's
once you get that, how they sync their clock is, I don't know. I guess I don't know the answer how vendors sync their clock in their hardware.
Okay, and the other one is if you issue a command out from SCADA, and down to the device, how do you know it actually got there? Because it has to hit the broker and then it has to go down.
You don't. The broker will inform you if the device goes offline. It'll send what they call a death message from the device. So you would see from VTScada that all the values would go invalid.
But if it didn't die, it just didn't work.
The protocol doesn't have. They use the fire and forget version of MQTT, so there is no direct feedback from that. Okay. That is a relevant point.
Okay.
I'm pretty certain it's set to QoS 0. So if you did use Sparkplug B, as Dave's saying, there's different qualities of service with MQTT. That's part of the transport that's defined. That can say there's 0, which is fire and forget, 1 is ensure it gets there, and level 2 is ensure it gets there only once. So we do support those different QoSs for MQTT in general, but if I recall correctly, Sparkplug B specification is QoS 0. Okay. Actually, the tags will show me right away because they'd have it set correctly. Yeah, they're the default QoS, so it would be 0. But yeah, if you're doing this, it's on the driver level. QoS, yeah. So the default's to 0 for Sparkplug B. I believe that Sparkplug B specification says that I'm almost certain that the QoS has to be 0 for it. Yeah.
So, kind of to your question, we went kind of old school on how we were doing it. So we're using a heartbeat that's out in the remote device that kind of cycles back through. So we're actually doing alarming off of that heartbeat if we have comm fails. So we're kind of doing a pretty basic old school method of doing it. But the commands, if you send a command out to start a pump or stop a pump or reset an alarm, if it doesn't go through, you know it because you click to start it. Because pretty much everything we're doing in our case here, you're commanding something. It's not automated from there out, but you kind of know it. And then we just use that heartbeat to ultimately determine something's wrong. And that's worked really well for us. It's tried and true. And then the time clock question that was asked, we've struggled with that, but we actually created like a sync bit in one case where we send out to update the clock. But then our other thing we did, as I mentioned, these are all cellular. So we started using the cellular to update our time clocks for what we're doing on the remote sites. And then everything stayed perfect with that. So that's worked really well. But time clocks have been a struggle keeping them synced for us, unless you're doing cellular.
Any other questions? All right, big round of applause for Trent.